Okay, so in this lesson we are going to talk more about strings and constants. In the last lesson I explained that in addition to variables, you can also create constants. I explained that with constants, you can read them but you cannot change them. I know that this is a mystery to many of you, and now we are going to cover this material in greater depth. First of all, as we have discussed in previous lessons, whenever you create a string of text enclosed in quotes, for example, this, then this string of text must be stored somewhere in memory. Let's go through the steps that C, or any language, must go through in order to do this. So first of all, C must find some location in memory to store the string of text. Then at exactly that location in memory, it's going to store the first character, which is a capital H. And then immediately after the H, at the very next byte, it's going to store the next character, which is a lowercase e. And then it is going to continue this process until all the characters of the string have been stored, and finally it is going to add a null byte, all zeros, at the end to terminate the string. Now keep in mind that this means that if your string of text is 5 characters long, there will actually be 6 bytes of RAM needed to store it. Now consider this code. String, the word string here, is a pointer. Every pointer contains a memory address. String, therefore, contains the memory address to where this string begins. In other words, it points to the letter H. It contains the memory address where the capital H is stored in memory. What if we now wanted to change this string of text to something else? Could we do this, for example? The truth is we can. However, it does not change anything. Like we explained before, all we are really doing is causing this pointer to point to a different string of text that is itself stored somewhere else in memory. Remember that string is a pointer, and pointers can only contain memory addresses, not strings, meaning not strings of text. This pointer, string, does not contain this string of text. It contains a memory address to where this string of text begins in memory. So when we write this code, what happens to the string of text, hello Reddit? It's still there. It's still sitting in memory exactly where it was. However, we have no way to find it now because we have changed where our pointer was looking. So consider this code. Okay, so first of all, we have our pointer named string, and we are pointing it to a string of text that is hello Reddit. Then we create a new string of text called a new string, and we're setting our pointer to point to the memory address of that. Now here we are setting our string pointer to point to a string of text that is in fact hello Reddit. Now this is where things get kind of interesting. With this third line of code, did we now set string to point to the memory address of a different string of text, or are we pointing to the original string of text? Remember, this string of text already exists in memory. When we write this particular statement, does this create a new string of text called hello Reddit, or are we saying to point this pointer to the string of text hello Reddit that already exists in memory? The answer is that it depends on the compiler. Many modern compilers will be smart, and they will figure out, why create a new string of text called hello Reddit? Let's just use the one we have. And in this case, string, the pointer string, will contain, once again, the memory address of the same string. In other words, this and this will be the same string stored in memory. C will store at some memory address and at a different memory address. But that's it. There's no need to, at yet another address, let's just line this up a little better. Yeah. And there we go. And yet at another memory address to have, once again, hello Reddit. There's no need to do that because we already have hello Reddit once. We don't need to actually create another string that is exactly the same at yet another memory address. Again, this depends on the compiler, but many modern compilers will understand that you've already created the string once and you don't have to do it again. So in these 3 lines of code, let's go ahead and give this an actual address just so we can understand this easier. Let's say this is position 8. Yeah, let's actually say this is position 1 and this is position 8. Now I don't think that that would actually fit, but let's just do that for the sake of understanding this lesson, or if we really want to be thorough. Okay, let's do that. So at this position in memory, position 1, there's going to be the string of text hello Reddit, and at this position in memory there's going to be a new string. So what we're effectively doing with this line of code is string is going to be pointing to here, yeah, which is here of course. Then with this line of code, string is going to be pointing here, which is here. And then with this line of code, string is once again going to be pointing to here, because they are the same string. Now again, this is depending on the compiler, and I'm explaining this to you just so that you have an understanding of how this works. So in many modern compilers, the compiler will be smart and figure, why create a new string of text, hello Reddit, at a different memory address? Let's just use the string we already have. However, the thing to keep in mind is that in general, when you set a string pointer to a new string, you are not changing the text. You are not locating hello Reddit in memory and then changing it to become a new string. Rather, you are setting the pointer to a new memory address where a new string is located. Now, the next thing that I want to discuss in this lesson is that there are different kinds of memory. Now, this is a bit misleading because memory is memory, regardless of what is stored in it. However, your compiler, as well as your operating system, have rules about which memory you can use for what purpose. These different kinds of memory exist as ranges of memory. And it works like this. A certain amount of your memory is going to be read-only, and a certain amount of your memory is going to be read and write, which means you can not only read what is here, but you can also change it. Now, this little diagram is only for illustrative purposes. The real details about how this works are more complex and are beyond the scope of this lesson, and you don't need to know that yet. What you do need to know is that different ranges of memory can be used for different purposes. Variables are placed in the read-write portion of memory. Constants are placed in the read-only portion of memory. Now, you might be asking, what is this read-only range of memory, and why does it exist? The answer is that as a programmer, some data you create must not change or it will cause your program to break. Let me give you an example. Suppose in a program I need to draw circles, and I put the mathematical definition of pi as 3.14159. Do I ever want that to change? No, I don't. I want that to always stay as the correct value. So I don't want my program to somehow accidentally change that value to something else. So in that case, I would store the value for pi in my read-only memory as a constant. That's an example of where you would use a constant. So when you, as a programmer, want to make sure that a constant doesn't change, then wouldn't it make sense if your computer worked with you on that goal? And that's exactly the case. C stores constants in a read-only portion of memory for your benefit. The idea is, if you define a constant, then you intend for that to not change. Now, as any programmer reading this will agree, C's idea of your benefit and your idea of your benefit can be different, but it is the thought that counts. At this stage, you should understand this. You should understand what is a constant. You should understand why do constants exist, and you should understand where and how are constants stored. Very briefly, let me go over this. A constant, unlike a variable, is data that will not change. You can read it, but not change it. Constants exist because sometimes you have data that you don't want to change. For example, the value of pi, you would want it to stay the same throughout your program, and ideally you would want to store that value in a place where it cannot change. And lastly, constants are stored in a read-only portion of memory, and the way that they're stored is that C will locate that memory address and store the constant there. Now there's one other point that I want to bring up, which is if you create a variable in your program and you create, let's say at a different line of code, you have a constant, which in this case is a string constant, they will not be stored in the same range of memory, which means you should never expect that one is going to be right next to the other in memory. They're going to be in totally different places, even in totally different ranges of memory. So that's just something that I want you to keep in mind in terms of how that works. Okay, so let's go back to this code. You may be wondering, why did the string of text hello Reddit get stored as a constant versus a variable? The answer has to do with C syntax. If you write this code or this code, they're the exact same thing. This is the same as this. Then C knows that you want this string of text hello to be a constant. We will talk soon about other ways to define strings of text in such a way that they are not a constant, but remember from here on out that using this method to create a string will make that string a constant. You are probably wondering, shouldn't you have to use some sort of keyword to indicate that the string is a constant? The answer is not in this case. It is implicitly understood by C that because we are creating a pointer that is a char pointer, and we are pointing it to a string that is enclosed in double quotes, that we intend for that string to be a constant. Now, that is an example of implicitly declaring that this is going to be a constant. You have used other examples of implicit keywords. For example, when you write this, you are implicitly saying that it is a signed integer. It's the same thing as if you wrote this. You don't need the signed keyword because int will assume that you mean the signed keyword. Remember that an integer is either signed or unsigned. It either has a signed bit or it doesn't. So this is just another example of an implicit keyword. Alright, so that concludes this lesson. If you have any questions, feel free to ask.